Assalamu alaikum students. I hope you are fine. Today we do the question number 3 of exercise 2.4. So let's begin with it. In this question we have 27, 60, 180 and 4 and 9 as composite numbers. So if we take their LCM to write their factors, 2 raised to power 1 over 3, 27 is equal to 3 multiply 3 whole power 1 over 3. 60 is equal to 2 2s are 4, 4 3s are 12, 12 5s are 60 whole power 1 by 2. 180, the factors of 180 are 2 2s are 4, 4 3s are 12, 12 3s are 36, 36 5s are 180. 4 is equal to 2 multiply 2 raised to power minus 1 by 3. 9 is equal to 3 multiply 3 whole power 1 by 4. 2 raised to power 1 by 3, we carry on. We apply law of sum of powers over here, and that is a raised to power m dot a raised to power n, that is equal to a raised to power m plus n. Powers are added if bases are same in a product. So we do the same over here. 3 raised to power 3 whole power 1 by 3. 2 raised to power 2 multiply 3 multiply 5 whole power 1 by 2. Whole divided by, again we apply the law of sum of powers. So 2 raised to power 2, 3 2 times, 3 raised to power 2 into 5 whole power 1 by 2 multiply 2 raised to power 2 whole power minus 1 by 3. 3 raised to power 2 whole power 1 by 4. In the next step, we apply law of power over here, and that is a raised to power m whole power n. So power is multiplied to the power, so that becomes a raised to power m n. So we do the same over here. 3 raised to power 3 multiply 1 over 3. 2 raised to power 2 multiply 1 over 2 multiply 3 raised to power 1 over 2, 5 raised to power 1 over 2. In that part, we apply law of power of product. That is AB whole power n, mean product having common power, that becomes a raised to power n multiply b raised to power n. And we do the same over here. 2 raised to power 2 multiply 1 over 2, 3 raised to power 1 over 2 and 5 raised to power 1 over 2. In the denominator, we again apply law of power product. So 2 raised to power 2 multiply 1 over 2, 3 raised to power 2 multiply 1 over 2, 5 raised to power 1 over 2. Applying law of power, which is discussed over here. 2 raised to power 2 multiply minus 1 by 3, 3 raised to power 2 multiply 1 by 4. We apply law of power. 2 raised to power 1 over 3, 3 cancel by 3 as they are reciprocal of each other. So 3, 2 raised to power 1, 2 is cancelled by 2, 3 raised to power 1 by 2, 5 raised to power 1 by 2, whole divided by 2 raised to power 1, 3 raised to power 1, 5 raised to power 1 by 2, 2 raised to power minus 2 by 3, plus minus minus, 2 1s are 2. 2 1s are 2 and 2 2s are 4. So therefore 3 raised to power 1 over 2 we have in the last. Like terms, as they are in product and division form, so therefore they can be cancelled. So 2 is cancelled by 2, 3 is cancelled by 3, 3 raised to power 1 over 2 is cancelled by 3 raised to power 1 over 2, 5 raised to power 1 over 2 is cancelled by 5 raised to power 1 over 2. Only 2 values are left, and we can apply the law of quotient of power with same base, and that is when we have a raised to power m over a raised to power n, and m is greater than n, so therefore n move to the m. So a raised to power m, as this is minus, that will become plus moving in numerator, so applying law of quotient of power with same base, we get what? 2 raised to power 1 over 3 plus 2 by 3. Taking LCM, 3 ones are 3, 1 ones are 1. Common denominator, we write the numerator same as. In the next step, we have 2 raised to power 3 divided by 3, which is equal to 2 raised to power 1. Finally, we get the answer 2 for this question. Now we do the part 2 of the question number 3. In this question, we deal with the radical expression. Along with, we have to apply the laws of exponent in this. So let's begin with this question. As we have two composite numbers, 216 and 25, we find their prime factors by taking their LCM, 216. It is an even number, so we divide it by 2. 2 ones are 2, 1 is less than 2, so therefore 2 zeros are 0, 2 eights are 16. 2 fives are 2 54s are 108, 2 27s are 54, 3 9s are 3 3s are 3 1s are 3. We get the factors of 216, and these are 2 2s are 4, 2s are 8, 3s are 24, 3s are 72, 3s are 216. So 216 raised to power 2 by 3. 5 into 5 whole power 1 by 2. 0.04 can be converted, transformed into 4 over 100 raised to power minus 1 by 2. We convert radical form into exponential in the same step. 4 ones are 4, 4 25s are 100. We simplify the denominator. In the next step, we apply law of power, law of sum of powers. So which is 2 raised to power, which gives us 2 raised to power 3, 3 raised to power 3 whole power 2 by 3. 5 raised to power 2 whole power 1 by 2. In the same step, we do what? We make this negative. We make this negative power positive according to law of quotient of power with same base. And now it becomes 1 over 25 whole power 1 by 2. In the next step, we apply law of power product. In that 2 raised to power 3 multiply 2 by 3. 3 raised to power 3 multiply 2 by 3. Law of power is applied. We have discussed many times earlier. So 5 raised to power 2 multiply 1 over 2. In the next part of this question, we have 25. And as we know that 25 is equal to 5 multiply 5, it means 5 raised to power 2. According to law of sum of power, 5 2 times 5 raised to power 2 we can write. So we write over here 5 raised to power 2 whole power 1 by 2. So 3 is cancelled by 3. We have 2 raised to power 2. 3 is cancelled by 3, so we have 3 raised to power 2. 2 is cancelled by 2, 5 raised to power 1. We apply law of power over here, 5 raised to power 2 multiply 1 over 2 whole power 1 by 2. 2 raised to power 2 multiply 3 raised to power 2, 5 raised to power 1 multiply 1 over 5 raised to power 1. 2 is cancelled by 2. 5 is cancelled by 5 because they are reciprocal of each other. Now we open this bracket, applying law of power of product, because two different values are in a product having common power. So 2 raised to power 2 multiply 1 over 2, 3 raised to power 2 multiply 1 over 2. 2 is cancelled by 2 in each term. So what we get now, 2 raised to power 1 multiply 3 raised to power 1 equal to 6. That is the simplified answer using laws of exponent of the part 2. Now we move to the part 3. In this part, we have to deal with two different writing pattern. And what we observe in the first part, 5 raised to power 2, but the 3 is the power of 2. It means 2 is repeated 3 times. So we write like that, 5 raised to power 2 multiply 2 multiply 2. Whereas divided by, we apply log power of power over here and we get what? 5 raised to power 2 multiply 3. 5 raised to power 8 divided by 5 raised to power 6 equal to 5 raised to power 8 divided by 5 raised to power 6. We write in the fraction form. Applying law of quotient of power with same base, which is a raised to power m over a raised to power n. When m is greater than n, that becomes a raised to power m minus n, and move to the numerator. So 5 raised to power 8 minus 6, 5 raised to power 2, it means 5 multiply 5, that is equal to 25. That is the simplified answer of this part. Now we do the last part of this exercise, and again we deal with the two different writing patterns as in the previous question. We apply law of power over here, and we get x raised to power 3 multiply 2 divided by x raised to power 3 raised to power 2 means 3 multiply 2 times. X raised to power 3, 3 raised to power 2, and 3 raised to power 2 means 3 multiply 2 times, 3 multiply 3. Now we get x raised to power 6 divided by x raised to power 9. Right in a fraction form, x raised to power 6 divided by x raised to power 9. Applying law of quotient of power with same base, x raised to power m over x raised to power n. That becomes 1 over x raised to power n minus m. Why? Because m is less than n. The value of m is less than n. That means 6 is less than 9. So we take x base as common in denominator. Bigger power retain its place, smaller power move to it. 9 minus 6, and we get final answer x raised to power 1 over x raised to power 3. That is the simplified form of question number 3 part 4.